Welcome to the future of data. Will AI data centers move to space? Discover the truth behind Google's secret project. Watch the full story next.
Picture this. Hundreds of miles above your city, thousands of high-performance computers are quietly circling the Earth. They pull energy directly from the sun, and there isn't a single cooling tower in sight. While this looks like science fiction, it is an active engineering goal. Companies like Google, SpaceX, and Axiom Space are already designing the orbital infrastructure required to push data centers out of our atmosphere. To understand the drive behind this move, we have to look at the ground. This chart shows the massive power gap between traditional computing and AI. A server running a standard website sips electricity, barely registering on the scale. But training a single large AI model requires tens of thousands of processors running simultaneously, demanding huge surges of power. All that electricity generates extreme heat. To keep those AI processors from melting down, tech companies have to construct colossal, resource-heavy cooling systems right alongside them. We are hitting a physical limit. Across the globe, new AI infrastructure is maxing out local power grids, eating up thousands of acres of land and draining millions of fresh water. The artificial intelligence industry is rapidly outgrowing the physical constraints of our planet. To keep scaling up, scientists are looking to the vast open real estate of space. At first glance, orbit offers exactly what AI needs. Depending on the satellite's path, you can harness continuous, unfiltered solar power. And up there, land acquisition costs are completely eliminated. It is easy to assume that because space is freezing cold, keeping a server chilled would be effortless, but that is a profound misunderstanding of physics. This diagram shows exactly how a satellite processes heat in a vacuum. On Earth, we use fans to blow heat away through convection, but in orbit, there is no air. The heat energy has nowhere to go. A high-powered processor will cook itself unless you attach massive radiator panels to emit that thermal energy directly into the void as infrared radiation. Then you have to contend with the invisible threats. Earth's atmosphere protects us from intense solar and cosmic radiation. Without that shield, highly sensitive AI chips will degrade and fail almost immediately. So while the solar energy is abundant, the environment itself is entirely hostile to computing. Keeping a single processor alive requires layers of complex, heavy engineering. To protect those chips from radiation, engineers have to surround them with dense physical shielding. And in aerospace, weight is your biggest enemy. Every extra kilogram of metal drastically increases the cost of the rocket launch. Breaking Earth's gravity is a massively expensive endeavor. And if something breaks, on Earth, a technician walks down a server aisle and swaps a part in 10 minutes. In orbit, a fried motherboard means you either launch a multi-million-dollar repair mission or write off the entire satellite. Even if you solve the hardware problem, you hit a severe communication bottleneck. Training modern AI requires shuffling terabytes of data back and forth between processors and users instantly. The bandwidth between Earth and orbit is simply too narrow to handle that load. Add up the launch premiums, the inability to perform cheap maintenance, and the communication delays, replacing our terrestrial server farms with orbital ones is economically impossible right now. Because of these limitations, large language models like ChatGPT will remain firmly planted on the ground for the foreseeable future. But there is an incredibly powerful application for orbital AI happening right now: edge computing. Instead of operating as basic cameras that blindly beam raw data downward, satellites can process information directly on board. Imagine a satellite passing over a remote forest fire. Rather than sending thousands of high-resolution images back to a ground station for analysis, the onboard AI scans the massive smoke plume in real time. It computes the threat size and trajectory itself, and then transmits a tiny, instantly actionable alert down to emergency responders. This instant processing strips away the communication delay. For rapid onset disasters like rising floodwaters or forming cyclones, saving those few minutes of data transfer can save lives on the ground. Naturally, this capability extends to military surveillance. Equipping spy satellites with AI that can instantly identify terrestrial targets creates a massive strategic advantage, which is already driving new geopolitical competition in space. All of this forces us into a difficult environmental paradox. Orbital computing saves land and fresh water, but assembling it requires a constant stream of massive rockets, depositing emissions into the atmosphere and crowding low Earth orbit with hazardous debris. We are moving toward a hybrid internet, a network that functions both on the ground and in the void above us. By anchoring our most advanced processors in orbit, we are pushing the physical borders of human civilization into the cosmos.